So in the last class, we have just started with universal law of gravitation, right? And I had given you couple of homework regarding it. So have you done that homework?
Yes, sir. I gave you my answer. Let me just check.
Okay. Prince, have you done?
Yes, sir.
Okay. So let me check your answers. Siddharth, did you get the answer?
No, sir. Actually, I had fevers. I was not attending the previous classes, so I don't know.
Pranaya,
Yes, sir.
uh, for the universal law of gravitation, I had given you a question to find out the force of attraction between sun and the earth.
Sir, I didn't attend the last class. If you want, I can do it right now. This.
Okay, no issues. Okay. Universal law of gravitation. So in the universal law of gravitation, we had done that the force between any two masses, if you have a mass m1, another mass m2, so the force between these two masses is directly proportional to the product of their masses. Okay. So force between them is directly proportional to the product of their masses. So that means we can write as force to be proportional to m1 into m2, right? And we also see that force is inversely proportional to the square of the distance between them. So this is the statement of the universal law of gravitation, that the force between two masses is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. Okay. And also it acts along the line joining the two masses. So here the mass m1, the mass m1 will be attracted towards m2. So M1 will be attracted towards M2. So M1 will experience a force along this direction. Okay. And M2 will also experience a force along the opposite direction. So the force between them will be equal. Force is M1 into M2 and inversely proportional to R square. By combining these factors, we obtain here that force proportional to M1 into M2 divided by R square. Now, if we want to remove this proportionality, so there must be a constant, and that constant value was determined to be G. So F equals the constant value G multiplied by M1, M2 over R squared. So this value G, we studied this value G is the universal gravitational constant. It is universal gravitational constant. Okay. And since it is an universal gravitational constant, so its value does not depend on any factors. It does not depend on the medium between them. It does not depend on any factors. It's universal constant. So everywhere in the universe, the value of the universal gravitational constant remains the same. Okay. There are no factors on which this universal gravitational constant depends. Right. So the value of this universal constant, it came out to be 6.7 into 10 to the power minus 11 Newton meter square per kilogram square. This is the value of universal gravitational constant G, right? So this much we had done in the last class. We saw that if the mass increases, so the force also increases proportionally. Okay, and we had seen one of the examples that how will the force increase proportionally. Okay, here if say suppose the force between M1 and M2 is 10 units. We had taken one example that the force between M1 and M2 is the force between M1 and M2 is, suppose it is 10 Newton. Suppose. Okay. So what will this force change if the distance is also same and instead of M1, the M1 mass is doubled? So what will be the force between them? Any idea?
double.
Yeah.
If the mass also increases, then the force also increases.
Okay. So if I double this mass of M1, so what will be the new force?
Double.
Double. The new force will be 20 Newton, right? If I double this mass M1 as 2 M1, so the new force will be 20 Newton. What will be the force if I double the mass M2 only, not M1? So what will be the force then?
Sir, then 20 Newton only.
Then only be 20, then also it will be 20 Newton. And what if I double both M1 and M2,
Sir, then 40.
then 40. So this was what I was trying to explain in the last class. And there was some a little bit confusion to you all because you were not getting how we are opting it out. Right? So have you understood everyone?
Yes, sir.
Okay. So it depends on the product of the mass. Okay, what will happen if I double the mass M1, I make it 2 M1 and I make this mass half, M2 by 2. So what will be the new force between them?
It will be constant, it will be the same.
It will be the
It will,
same.
it will be
Opposite
the
charge.
same. Okay. Now what will happen if the masses are same but the distance between them is doubled?
Then it will decrease by 4 times.
By be increased.
It will decrease and it will become 1 by 4 of the original force.
Yes.
Okay. If you decrease the distance between them by r by 2, so what will be the new force?
Then it will be 4F.
Then it will be 4f. So Chavan Kaushik, are you getting?
Yes, sir.
Okay. So this was what you were not getting in the last class.
Yes.
See, also the homework that I gave you, I will show you how to solve such big calculations. The calculations seem to be very big, but they are quite small. So we'll see that problem. Then we'll also calculate the force of attraction between Earth and the Sun, Earth and the Moon. Okay. So first we calculated in the last class, we calculated the force between Earth and Sun. So what is the force between Earth and Sun? Here we object, suppose this is our Sun and we have the Earth. Okay. So we want to find out the force between them, right? So we had given the mass of Sun and mass of Earth. So here this was the mass of Sun and this was the mass of Earth. So the mass of Earth was given out to be, what was the mass of Earth?
6 point. Okay, mass.
6 into 10 to the power 22 or 24? What was the mass?
24.
24 kilogram. And mass of Sun was 2 into 10 to the power 30 kilogram. Am I right?
Sir.
Check. Okay. And the distance between them, that was equal to 1.5 into 10 to the power 15 meter. Yes, this was the distance between them. So if you calculate the gravitational force between them, it will be equal to, we'll apply the formula G into M1, M2 over R squared. Right. So the force of gravitation between them will be equal to F equal 6.7 into 10 to the power minus 11. Then you have multiply mass of sun. See, here you need to understand how to perform these calculations. Okay. So then you have the mass of sun, which is 2 into 10 to the power of 30. Then you have multiply mass of earth, which is 6 into 10 to the power 24, divided over 2 into 10 to the power 30 whole squared. So this is what we have, the mass, the force between two objects, right? Now the force between these two objects can be calculated. The distance was 2 into 10 to the power 15, not 30. I've written here 30. This was
Yes,
15.
sir, but with this big of a number, it's very easy to make a calculation
Or
error.
not? Yeah, it's very easy to figure.
No, it's very easy to make a mistake in calculation.
No, so it's very easy to make a mistake. So that's what I'm saying. It has to be very simple and short. Okay. Your first point is that you have to collect all the powers of 10. Collect all the 10s. Okay. So from the numerator, we have 10 to the power 30 plus 24 minus 11. Right? Okay. And whatever else is left in the numerator, write it over here. You have 6.7 multiply 2 multiply 6. So you write this over here. Then in the denominator, if you square this, you will have the square of 1.5, and square of 1.5 is 2.25. Okay. Multiply, it's 10 to the power 30. Now take this 10 to the power 30 also to the numerator. So your calculation is now divided into two parts. Okay. You can write this calculation to be as this 6 into 2 is 12. So 12 into 6.7 divided over 2.25. So keep it as it is and resolve the powers of 10 at the other place. Okay. So 10 to the power 30 in the denominator, it will move to the numerator. It will again be 10 to the power 30 in the numerator, minus 30. And if you solve it out, you are going to get 24 minus 11. That is going to be 13, right? If you take this 10 to the power 30 also to the numerator, it will become minus 30. And this is what you get finally.
Yes, sir. Okay, I understood.
Okay. So Siddharth, are you getting?
Yes, sir.
Harini,
Yes, sir.
see, you should know how to make the calculations over here. There is nothing big in these questions. Only the calculations seem to be tough, but they are not tough. Neha, turn on your camera. I should say, tell everyone, all those cameras which are off, they should be on. Neha, Rikshit, everyone turn on your camera. Okay. So now you just have to perform this calculation. Multiply 12 by 6.7 and divide it by 2.25. So do it separately. Just do this calculation separately and you just have your answer multiply by 10 to the power 30. So I hope everyone is getting this.
Yes, sir.
Okay. At the end of this question, you might need to shift the decimals as per the requirement of the scientific notation, but that is the last point. You should be able to get up to this. And once you are here, then you just need to perform some rough calculations. Okay. You need to perform here 12 multiply 6.7, multiply, get your answer. If you get your answer, then divide that answer by 2.2. So we will see the force of attraction. Now we will try to calculate the force of attraction between Earth and Moon. So now you will calculate. I'm telling you the figures. between Earth and Moon. Okay. So here the data is given as, you know, the mass of Earth. So here mass of Earth, which is 6 into 10 to the power 24 kilogram. You have the distance between Earth and Sun as 3 into 10 to the power 8 meter per second. 8 meter, this is the distance. And mass of Moon is 6.7 or 7.2. Just let me check. Okay, anyone has memorized the value of mass of Moon?
Sir, 7.4 into
Yeah, it's
10 ki power
it's 7.4
22.
10 to the power 22. Okay, so it's 7.4 into 10 to the power 22 kilogram. So find out the force of attraction between them. Siddhisri, Neha, are you there? Neha, so why your cameras were off? Rikshit,
Sir, mine is on.
Put in group
yeah,
also.
fine. So are you solving? Neha, are you solving the problem? Okay, solve it out. I want your answer, Neha, and send your answer in the chat section. Then I'll be checking your copy. Pranay, are you solving?
Yes, sir.
Okay. Yeah, Oro Smith, have you calculated?
I'm doing.
Okay. No one will take the help of any calculator. Siddhant,
Yes, sir.
have you done?
So I'm still doing, sir.
Okay.
Sir, should I send you the answer?
Okay, have you done?
Yes, sir.
Siddharth has sent the answer. Siddharth, can you show your calculations? Yeah, Siddharth, can you show your calculations?
Sir, that was the last.
Yes,
Sir, that was the last problem.
that was the last problem. Okay.
Sir, I sent you the answer.
Hmm. Okay, Siddhi has sent answer. Harini. Harini, is that the answer to this question or the previous one?
Sir, this question.
Okay. I don't think it's correct. Check. Okay. I'm checking it out just.
Okay, sir.
Okay, anyone else who has done? There are two answers I've got. Neha has sent the answer. Pranaya. Okay, fine. So I think now I need to see. See, I think up to here everyone has got the same.
Yes, sir.
So after this, you just need to perform this calculation 6.67 multiply 6 and multiply 7.4. Okay. So if you multiply them, you get here 297.48 and 297.48 divided by 9, it gives you 33. So you have here 33.05 multiply 10 to the power. You can add this 16 and 11. So 16 and 11, it becomes 27, right? And subtract this 27 from this, it becomes 19, 10 to the power 19. Again, is it correct?
Sir, I took approx value.
Sir, I got 33 into 10 to the power 17.
17. Okay.
Sir,
So
I
see
got
here.
Sir, I
Okay,
also got that 17 once, 17.
okay. See, minus 11 plus minus 16, it will be minus 27. If you add 24 plus 22, it will be 46, right? Okay. So you get 21.
Sir, it is 10 to the power 19.
It's 19, sir.
19.
Yes,
Okay.
sir.
Yes, sir.
Now, yeah. So if you convert this again to standard form, you get 3.3 into 10 to the power 20. So these are the possible answers which you can have. Either 33.05 into 10 to the power 19 or 3.3 into 10 to the power 20. Okay.
But sir, here I
So,
got 2.2, sir.
no, that's incorrect. You might have made somewhere mistake. Can you show your calculations?
Sir, I did it like roughly. So how do I show
Yeah.
it? I
Where
just
did you
did
do?
rough calculations. How do I show it?
Okay, so that's why I do it at somewhere so that it can be checked out. Even in your exams.
Sir, I
Even
got
in,
33.3 into 10 to the power 18.
33.3 into 10 to the power 18. So that's also incorrect. At least your power should be correct. Okay,
Okay,
either
sir.
you should be okay. So your power should be correct. Just check your power calculations where your power went wrong. Why your power is incorrect? Incorrect. Else
So
everything
first I got 19, then I minus it to 18.
is why. Check it out over there.
Sir,
So
I
I
got
think
it correct, sir.
you got the same.
Yes, sir.
Oh, sir, yeah, I checked again. Some calculation mistake.
Okay. So everyone knows now how to calculate Arrowsmith.
Yes,
Your
sir.
answer. Did you send your answer?
No, sir, I told you.
Okay. Aman, what about your answer?
Sir, I didn't send it, but I did it in my paper.
Okay, so it's the same.
No, sir, I got something wrong.
Sir, I did a calculation mistake in the
So
last.
where were you wrong? In the powers or in the numbers?
In the value.
In the values. So again, simplify the values. Okay, don't cancel it out. Simplify. First multiply, then divide. Okay. If it's getting cancelled completely, then you cancel. Like here, you can see that this is getting cancelled completely 3 times, and this will get 2 times. Okay. Then this 3 would also get cancelled if you just take a approximation. If you can approximate this 6.7 to 6.6. So you will get here 3.3. Now you can multiply 3.3 into 2, that will be 6.6.
Sir, it's 2.2, right?
Yeah, it will be 2.2.
Sir, I did the
So,
same thing and I got 32.56
okay,
into
okay. So it would be 2.2 multiplied to 4.4. Multiply that 4.4 by 7.4.
Sir, then it will be 32.56. I did the same thing.
Yeah. So that would be 4.4 into 7.4 if you will. So it can be considered as correct. Okay. Provided your power here should be the same. Your power you are getting as 10 to the power 19.
Yes, sir, 10 to the power 19.
Yeah, then it's correct. Fine. Okay. Now we'll move towards the next part of it. Since we have done the gravitational force, now we will do a small part that is Kepler's laws of gravitation. See, we just saw the Newton's law of gravitation. The Newton's laws of Newton's law of gravitation. It is also called as the universal law. It is also called as the universal law. So here Kepler's law, they were quite before the Newton, and according to the Kepler's law, there are 3 laws of Kepler. The first law, that is called as the law of orbits. So first law is the law of orbits. Then you have the second law, which is the law of velocity or the law of areas. So first one is the law of orbits, which state that all the celestial bodies or all the planets, they revolve around the sun in elliptical orbits. So it's something like this now. It states all the planets all the planets revolve around the sun in elliptical orbits with sun at elliptical orbits with sun at either focus. With sun at either focus. So we'll understand this, what it means. See, it means as we see that the orbits of planets seem to be circular, but they are not circular. They are elliptical orbits. And with this phenomena, with the elliptical orbit, we are able to explain a number of phenomena related to Sun and Earth, like the occurrence of the season. It is explained on the basis of the elliptical orbit and not on the circular. So the orbit seems to be something like this, with Sun at either of the focus. So we consider the Sun to be at the focus over here somewhere, not in the center. So the Sun is not at the center, the Sun is somewhere at the focus. So the focus of an ellipse, it lies to either side. So there are two focus of an ellipse. This is the center of the ellipse. Okay. So this one is the center of the ellipse. Okay. Sun can be either at this focus or it can be at this focus. There are two focus which are located on either side. You'll learn more about the focus in your higher classes. In class 11, you'll learn more about focus. Okay, so Sun will be here and all the planets, they are revolving in their orbits. So that means if you consider the Earth and other planets, they are revolving in these orbits. Okay, so this is the reason we have the occurrence of season. When the Earth is far off from the Sun, then you have winter season, and when the Earth comes close to the Sun, that means in these areas, so you have the summer season. Okay. So this one is the law of orbits. They are the planets revolve around the sun in elliptical orbits. Then the second law is the law of areas. A law of second one is law of areas, and it states that planets revolve around sun with constant elliptical constant aerial velocity. So planets have a constant aerial velocity. We will talk of what do we mean by the aerial velocity. Yeah, Aman. Aman, what happened? Is there any issue, Aman?
No, sir.
So I think you raised your hand, so that's why I'm asking. Okay. See. So this is how I told you that the Earth or the planets, they are revolving around the Sun in the elliptical orbits. Now the meaning of this law of areas or the planets revolving around the Sun in with constant aerial velocity, it means something like this, that let us join the Sun to the Earth with this radius. This will be the distance between Earth and the Sun. Now, after some time, our Earth, let's say after some time delta t, I observe the Earth to be at my new position. Okay. So the Earth is now at this position after some time delta t. Okay. So this is the time delta t. At the beginning of the time, the Earth was here. Then after that, the Earth came over. So this was the delta t, which was the difference of time. The Earth has traveled this much of distance, right? So understand everyone that Earth has traveled from this position, let's say position A to position B. Okay, no problems here. Okay. Now, what is the area? Area that has been traveled. If I mark this point O, so Earth has traveled an area of AOB. Area AOB has been traveled by the Earth in the time delta t. Okay. Now, if I consider when the Earth to be very far off, let's say Earth is here. Okay. Now, in the time delta t, the Earth will be at a new position. Let's say somewhere here. The Earth is at a new position. So the distance traveled by the Earth. Okay. Now here let this be P and Q be the points. And now the Earth has traveled from P to Q in time delta t. Okay. So it means if here also the time is same, here also the time is same. So the area of AOB should be equal to the area of POQ. This is what it means with the aerial velocity. You can also say that the aerial velocity means area divided by time. So the area of triangle AOB divided by delta t, area of triangle POQ divided by delta t is equal. So this means that the planet has a constant aerial velocity. Okay. No need to worry about much of it, as you do not have any numericals or any numerical problem based on this. You don't have any numerical problem based on the aerial velocity, but this is a good thing that if you are able to understand the concept of the aerial velocity. Okay. So are you getting this concept? Okay.
Yes.
So this is the area that must be equal. The planet must sweep out equal areas in equal intervals of time. It also means that when the planet is close to the sun, so it has to revolve faster. Okay. So since if you see for here, the planet has to sweep out equal areas in equal intervals of time. So see, both the areas will be same only if the planet will revolve faster when the planet is far close to the sun, and the planet revolves slower when it is away from the sun. So understood this concept of aerial velocities?
Yes, sir.
Understood? Okay. So this is for all the planets. All the planets do it in the same way. They travel with constant aerial velocity. This is the law of areas. Okay. This was the second law. Then the third one is the law of periods. You have law of periods.
Sir, for us, they haven't actually taught all of these.
Okay, so that's what I'm saying. There you don't need to worry about any numericals regarding this. Okay, but since here we are studying for some extra knowledge and some better education. Okay,
Okay.
this is a part of the gravitation. So the law of periods, it states that the square of time period of revolution, okay, it might be given in your book. Somewhere it is given in your book, you can look for it. Okay, it's not that it's not given. You will find it. So square of time period of revolution.
That's not there in the NCERT textbook.
Okay. Okay, fine. As a part of information, earlier it was given, and now it may have been removed out of it. Okay. So square of time period of revolution is directly proportional to the cube of its cube of its radius, cube of its mean distance from the sun. So it is the gravitational force which is holding all the planets together. Okay. So therefore, all the planets, they obey all these laws. They obey the law of periods. They obey the law of uh, areas. All these laws, they are obeyed. So here it states that t square, or the time period of revolution, is directly proportional to the t square is directly proportional to r cube. The time period of revolution is directly proportional to r cube, or cube of the distance of the planet from the sun. So are there any problems in the Kepler laws of planetary motion? Okay, how many of you had thought that the planets revolve around the sun in circular orbits with sun at the center?
Me, sir.
Okay. So most of us think that sun is at the center. Sun is not at the center, sun is at the focus. Okay.
Sir, but this is not in our syllabus.
Okay, no issues. We have covered it.
Will it come next year?
No, next year also it won't come. It won't come in, it will come in grade 11 also only, or you must know this. This is a very good information for you. Okay. Some of you may be having this, the Kepler laws of planetary motion. Okay. So that's why there are no numericals based on this, but just for your knowledge, you should know the law of Kepler, right? So after this, we move towards the gravitational force as the centripetal force. This next concept is the centripetal force, and this one is important. This is not given in your book with this name, but this one is important. The centripetal force. Okay, so anyone knows anything about the centripetal force?
Sir, the force that pulls towards the center.
Okay, it is a force that centripetal force is the force that always acts towards the center. Okay. So how we observe the centripetal force, let's see. Centripetal force. Centripetal force, it acts on an object when object revolves in a circular. When any object is following a circular path, so in that case, so let's see, if an object revolves in a circle, so as we know that the motion in a circle is an accelerated motion, right? If any object is moving in a circle, so motion in a circle is an accelerated motion, and here at every point of time, suppose if I see over here, so at this point of time, the object is moving in a circle with a velocity that is tangential to the circle. So at every point, the velocity is changing its direction. Even if the object is having a uniform circular motion, then also the velocity changes direction. Let's say at this point A, if I observe, the velocity has a certain direction. Let's say this is the velocity V. Now at this point B, I observe that the direction of velocity has changed. Okay. So when an object is moving in a circle, its magnitude, its velocity changes. When I say its velocity changes, uh, it means the direction of the velocity changes. I'm not talking of the magnitude. I'm just talking of the direction. So the direction of the velocity changes. Magnitude may also change, but at least a constant force is required for the velocity to change its direction. As per the Newton's laws of motion, an object will continue to be moving in a straight line only. It cannot change its path. So here we observe that the object is changing its path, and for this the object must require a force towards its center. and the force that is applied towards the center, that is the centripetal force. So here a centripetal force is required towards the center. Suppose you're trying to revolve a stone tied to a thread. If you tie a stone to a thread and try to revolve it in a circle, okay. So the stone requires a constant force. The stone requires a constant force to travel in a circle. It cannot travel in that circle if you leave it. If you leave the thread, so will the stone revolve in circle or will it go straight?
So it will go straight.
It will go straight.
Tangent.
So we
So-
learned this as inertia of direction, right?
Yeah, you learned this, but this we are going to apply here, that a constant force is required towards the center, and this force which is required towards the center to keep it moving, that is the centripetal force, right?
Yes, sir.
Okay. So what the gravitational force is doing? The sun is applying a gravitational force on the planets, and therefore the planets are revolving around the sun in their orbits, and hence a centripetal force is required. Okay. So the gravitational force of the sun, it is always providing the centripetal force. Okay. The gravitational force of the sun, it always provides the centripetal force. Okay. So here the centripetal force required for the motion of the planet, the centripetal force required by the satellites or the moon to revolve around the earth or any other planets, that is provided by the gravitational forces. Then this is for some better knowledge. The centripetal force is given by the formula mv squared over r. You may be required in a very high situations, maybe very rare. Okay, if you are attempting some Olympiad questions, so then only you may require this. The centripetal force is given by mv squared over r, where m is the mass of the object, v is the speed of the object, and r is the radius of the orbit. Now, so these were the three laws of Kepler. Then we did the centripetal force, and now we need to understand about the acceleration due to gravity. So acceleration due to gravity. First, before I talk about the acceleration due to gravity, let's talk of gravity. So is there any difference between gravity and gravitation?
So there is.
Yeah, what is the difference between gravity and gravitation? Just when I say gravity and gravitation.
So like gravitation is for the like the whole universal law of gravitation, while gravity is just for the earth.
Okay. So when we talk of the force of gravitation of Earth,
So
the force of
gravity is like a force of attraction. For example, you say an object and the earth,
Hmm.
and gravitation is like when gravity the force gravity is used to pull the object.
Okay. So the force of gravity, it is exerted by the Earth. When we are considering the Earth, when Earth is applying some force of gravitation on some object, so we say it as the force of gravity. We call it as the force of gravity. Not gravitation. So gravitation is in general case. When you are talking of in general case for any that, for example, if I say what is the force of gravitation between Saturn and the Earth, Okay. So the force of gravitation between the Saturn and the Earth. What would be the force between Saturn and the Earth? So that is gravitation. When I say what is the force between other celestial bodies, so that is gravitation. When I am talking with what force Earth is attracting a ball, with what force Earth is attracting a satellite. So in that case, I am talking of gravity, not gravitation. So I hope the meanings are quite clear with the gravity and gravitation. Gravity is the force referring to Earth. Okay. Force of gravitation of Earth. When it is for Earth, so we call it as gravity, and this is in general for any object. This can be called as in general for any object. Acceleration due to gravity, then gravitation, right? So now we move towards the acceleration due to gravity, and here we determine that if any object is lying on the surface of the Earth, if you observe any object to be lying on the surface of the Earth, what is the amount of force that object will experience due to Earth? Let us suppose that this is our Earth, and on the surface of Earth you have an object anywhere. Suppose if an object over here, anywhere you have an object. Let us suppose if you have an object over here, and I want to find out that what is the force between them. Okay, so the distances are always measured from the center, and Earth center is over here. So therefore, there is always a distance between this small mass which is placed on the surface of Earth and the Earth, right? The object is on the surface of Earth, but the distances we always measure from the center. So here, the distance between them will be equal to the radius of the Earth, right? Okay. So what will be the force of attraction between them? Yeah, what will be the force of attraction between them? Between the Earth and the object?
Gravity.
Gravity. So can I calculate its value?
9.8 per second square.
Okay. So this force will be not 9.8. We find it as F. The force will be G times mass of Earth, which is m1, multiply the mass of object, which is m2, divided by the distance between them, which is r squared. Right? This should be the force between them. Any doubts?
Yes, sir.
Yes. Yes. What is doubt? Yeah. Who is having a doubt? Okay. So we will see after this. We will see in the next class. Up to now, we see that the Earth attract every object, and the force of attraction between Earth and that object will be equals to G m1 m2 over r squared, where m1 is the mass of Earth and m2 is the mass of object, right? And r is the distance between them. Okay. So bye everyone. Good night.
Good
Right,
night,
yes.
sir.